Jupiter is not what you think it is. In fact, almost everything you were taught about Jupiter in school is either outdated or simply wrong. Jupiter is not a giant ball of gas. It is not a peaceful background object quietly orbiting the Sun. And it is definitely not a solved chapter in astronomy. For most of modern history, scientists believed Jupiter was little more than a massive atmosphere wrapped around a small, dense core, a simplified model that made sense with the limited data we had. But that picture didn't survive contact with reality. Because the truth is, we didn't actually start understanding Jupiter until very recently. It wasn't until NASA's Galileo mission in the 1990s and later the Juno spacecraft, which arrived at Jupiter in 2016, that decades of assumptions began to collapse. What those missions revealed forced scientists to rewrite textbooks, not refine them, but replace them. Jupiter turned out to be stranger, more violent and more important than anyone expected, and once you understand what Jupiter really is, you also realize something even more unsettling. Jupiter didn't just shape the solar system. At one point, it nearly destroyed it. In the earliest days of the solar system, nothing was stable. The Sun had just formed, surrounded by a vast, rotating disk of gas, dust, ice, and rock. Inside that disk, countless small bodies, planetesimals and protoplanets, were colliding, merging, and slowly growing into worlds. And then Jupiter formed. But Jupiter didn't grow slowly. It grew fast, dangerously fast. As Jupiter gained mass, its gravity became overwhelming. It began carving through the disk like a wrecking ball, capturing material, flinging debris outward and pulling itself inward toward the Sun. This process, known as planetary migration, turned Jupiter into a destabilizing force. Asteroids were slingshotted in every direction. Some were ejected into interstellar space. Some were hurled directly into the Sun, and others were sent barreling toward the inner solar system. At the same time, Jupiter's immense gravity robbed nearby worlds of material. Mars, in particular, had its growth permanently stunted. Instead of becoming a true Earth-sized planet, it was left underdeveloped. A planetary embryo that never reached its full potential, and Earth came dangerously close to suffering the same fate. Had Jupiter continued migrating inward, it would have cleared out the very region where Earth was forming, stripping away the raw material needed to build a habitable world. In that scenario, Earth may never have existed at all. What stopped it was another giant. As Saturn formed farther out, its own gravity began to interact with Jupiter's. The two planets entered a gravitational resonance, a kind of cosmic tug-of-war. That interaction reversed Jupiter's inward spiral. Together, Jupiter and Saturn migrated outward, retreating to the outer solar system, and in doing so, they left behind just enough material for the inner planets, including Earth, to finish forming. Jupiter was both destroyer and savior. The same planet that nearly erased the inner solar system is also the reason it exists at all. And this was only the beginning of how wrong our understanding of Jupiter would turn out to be. At some point, almost everyone learns the same phrase: Jupiter is a gas giant. It sounds reasonable. It looks like gas. And compared to Earth, it has an extremely low density. Only about a quarter as dense as our planet, so the conclusion seems obvious. But this is where the misunderstanding begins. Calling Jupiter a gas giant is a shortcut, not a description. It tells you what Jupiter is mostly made of: hydrogen and helium, but it says almost nothing about what Jupiter actually is, because composition is not the same thing as physical state. Hydrogen and helium don't stay gaseous just because they're light. Under extreme conditions, they behave in ways that feel more like science fiction than planetary science. And Jupiter creates the most extreme conditions of any planet in the solar system. As you move deeper into Jupiter, gravity increases rapidly, pressure climbs, temperature rises, and at a certain point, gas stops behaving like gas at all. There is no boundary where you can say, "This is the surface of Jupiter." There is no solid ground, no crust to stand on. Instead, Jupiter transitions smoothly and relentlessly from atmosphere to fluid to something far stranger. Jupiter isn't a ball of gas. It's a planet with no surface, where matter is crushed into new states that simply cannot exist on Earth. And the first hint of that reality begins in the clouds. From a distance, Jupiter's surface looks familiar. Swirling bands, towering storms, a giant red spot that's been watched for centuries. But Jupiter's clouds are not like Earth's clouds, not even close. High in the upper atmosphere, temperatures plunge below -100 degrees Celsius. Under those conditions, water should be completely frozen. And yet, liquid water exists. The reason is ammonia. Ammonia acts as a natural antifreeze, lowering the freezing point of water and allowing liquid droplets to form inside Jupiter's clouds. These droplets collide with ice crystals, and as they do, the clouds become electrically charged. The result is lightning. Not occasional flashes, but planet-wide lightning storms, raging constantly across Jupiter's atmosphere. As these supercool droplets continue to collide, they clump together into slushy, half-frozen hailstones, a mixture of ammonia and water. Scientists call them mushballs. These mushballs fall deep into the atmosphere, where rising temperatures cause them to melt, evaporate, and rise again, fueling a massive, continuous atmospheric cycle unlike anything on Earth. And driving many of these processes is Jupiter's most famous feature, the Great Red Spot. This is not just a storm, it is a planet-sized anticyclone, spinning counterclockwise with winds that can exceed 400 kilometers per hour. It has been raging continuously since at least the 17th century, older than modern astronomy itself. The Great Red Spot stretches hundreds of kilometers downward into Jupiter's atmosphere. It rises higher than surrounding clouds, absorbing more ultraviolet radiation from the sun, which triggers chemical reactions that give it its deep red color. To understand its scale, imagine a storm cloud 10 times taller than Mount Everest and 10 times deeper than Earth's oceans. And even that comparison falls short, because as massive as these storms are, they're still just the outermost skin of Jupiter. A thin, violent veneer covering something far more extreme below. And beneath those clouds, Jupiter stops behaving like a planet we recognize at all. Imagine falling into Jupiter. There is no moment of impact, no surface to crash into, just a slow, unstoppable descent. As you sink beneath the visible clouds, everything begins to change, not abruptly, but relentlessly. Jupiter's gravity pulls harder with every kilometer. The atmosphere grows thicker, pressure builds, heat accumulates. This heat does not come from the sun, it comes from compression. When gravity squeezes matter tighter and tighter, energy concentrates, temperature rises, and deep inside Jupiter, this process is taken to an extreme that no planet on Earth can replicate. The further down you go, the less hydrogen behaves like a gas. At roughly 1,000 kilometers beneath the cloud tops, the pressure becomes so intense that hydrogen molecules are forced closer together than they have any right to be. At this point, hydrogen gas undergoes a phase change. It becomes a liquid, not because it's cold, but because it's being crushed. This is the closest thing Jupiter has to a surface, an endless rolling ocean of liquid hydrogen. And it is enormous. This hidden ocean stretches roughly 20,000 kilometers deep, making it the largest ocean in the entire solar system, about 2,000 times deeper than Earth's oceans. There are no waves, no light, no horizon. Just a vast, opaque sea under unimaginable pressure. This is where the gas giant idea finally collapses completely. Jupiter is not made of gas with a little liquid mixed in. It is a liquid planet wrapped in a thin atmospheric shell. But even this ocean is only the beginning, because as you continue to descend, Jupiter becomes something even stranger. As the descent continues, the pressure reaches levels that defy intuition, millions of times greater than the pressure at Earth's surface, temperatures climbing toward 10,000 degrees Celsius. Under these conditions, liquid hydrogen undergoes another transformation, one that doesn't naturally occur anywhere on Earth. The hydrogen becomes metallic. This doesn't mean it turns solid like steel. It remains a liquid, but a liquid with metallic properties, something closer to mercury than water. Here, Jupiter's gravity squeezes hydrogen atoms so tightly that their electrons are forced to break free. Once liberated, those electrons move freely through the liquid, and that changes everything. Because free-flowing electrons mean electrical conductivity. This layer of liquid metallic hydrogen, stretching for nearly 40,000 kilometers, makes up the majority of Jupiter's interior. It is vast, dense, and electrically alive. And as Jupiter rotates, once every 10 hours, this immense churning ocean of liquid metal acts like a planetary dynamo. It generates colossal amounts of energy. This is the true heart of Jupiter. Not a solid surface, not a rocky crust, but a deep, rotating ocean of electrified liquid metal, something closer to a failed star than a conventional planet. This single discovery rewrote our understanding of Jupiter, because once you realize that Jupiter is powered from the inside by liquid metal, everything else about the planet, its storms, its radiation, its magnetic field, even its influence on the solar system, suddenly starts to make sense. And yet, beneath even this alien ocean, there is still something waiting. Something scientists once thought they understood, and now realize they don't.